Hey everybody, welcome to today's Getting Started with Kubernetes and Rancher 2.0. I'm just gonna wait a moment for everyone to join the line. And while people are joining, I'll go ahead and let everyone know that this session is being recorded. So you will get a email after this session, hopefully in the next 24 hours with the recording and the slides and the Q&A. So yeah, it looks like we got a lot of people on the line. I'll dive right in since we have a lot to cover and we have about 90 minutes scheduled for this session. So again, welcome. This is an intro to Kubernetes using Rancher 2.0. We hope to give you kind of a solid fundamentals of plain vanilla Kubernetes, as well as how it works with Rancher and what you can get done using both of those open source technologies. So if you're new to both, this is great. This is a great session for you. If you are familiar with another version of Rancher or another container orchestrator, I think you'll get a lot out of the session as well. And again, this is educational. We do have a lot of slides, but we try to make this as hands-on and interactive as possible. So we will be showing a lot of demonstrations, and please put your questions in the chat. You can put them in now, and we can kind of tailor the session for you. We will be taking breaks as we go through the material to answer questions. And for some of you who have been on these trainings before, for these intro trainings, we covered similar material each week. We do have more advanced trainings that we are working on to get into the calendar and up for Q4. But if you have been here before, hopefully you will get something as well, and can ask questions and tailor it to you. So that being said, as a way of introduction, my name is Matthew Shear. I'm kind of like the community advocate for Rancher, and our trainer on the line is Rajashree, software engineer who has done these a few times and is kind of an old hat. Thanks, Rajashree, for being here and being able to do this. Super appreciate your time.
Sure, thanks for having me here.
Yeah, absolutely. So just a little bit more context. We do hope you come in with some concepts around containers and Docker. And if you don't, I think you'll still get a lot out of the training. There's a lot of material on our blog and online for Docker itself. But if you have questions about how containers work, you can ask them here too, and we will try to get you in. Also, if you want to follow along with your own instance of Rancher going, you can get one deployed in just a couple minutes. Go to our website, rancher.com, and click the deploy button in the top right. It'll bring you to a quick start guide, and you'll be able to get started. Also, there are a ton of community resources. This is open source technology that is from top to bottom free to use. So please plug in and ask your questions and contribute on our Slack or forums, slack.rancher.io or forums.rancher.com. And there's a lot of activity there, and our engineers are there, and we check in on those platforms regularly. So now that we have all of that out of the way, we can finally get to the material. And so at this point, I'm gonna pass this off to Rajashree, who can really get us going here. So I'm gonna give you the reins of the presentation.
Sure.
And cool, I can see your screen. So you're good to go.
Cool. Yeah. Okay. So once again, welcome everyone to the Rancher 2.0 and Kubernetes training. I am Rajashree Mandavgade, and today, we'll be covering first of all a few slides where we go through some of the core Kubernetes objects, and then we'll have a demo for some of the Rancher 2.0 features. So I'm a software engineer, and I started working with Rancher Labs, I think around 2.5 years back. And when I first joined Rancher, that was the first time I learned about container orchestration. So like Matthew said, we hope you all are familiar with the concept of containers and Docker. But just having a containerized application isn't really enough. Like you need something that will make sure that your containerized apps are available all the time and get scheduled properly. Meaning you won't just have containers of your app running on just a single node, right? Like you would like to have them distributed across multiple nodes so that they are always available. And while doing so, you shouldn't have to worry about whether a particular node has sufficient resources left for it to run a container. So that's where a container orchestrator comes into picture. It makes sure that the user doesn't need to worry about these things. It usually comes with a scheduler that can schedule your containers across different nodes uniformly. It also makes sure that your containers remain available on the time all the time, meaning if one of the containers were to go down, it usually has a way of bringing up another container in its place. Then it sets up networking so that the communication between your containers is very easily possible. It's also responsible for the storage, HTTP load balancing, health checks, monitoring, and all. So yeah, a container orchestrator has many benefits for running your deploying and scaling your applications. And Kubernetes is such an example of something that lets you easily deploy and scale your apps. So when I first started working at Rancher, we were working on the 1.x versions of Rancher, which is like Rancher 1.3, 4, and so on. And that time, we provided support for Kubernetes as one of the container orchestrators. But along with that, we also had support for some more orchestrators, such as Docker Swarm and Mesos. And we also had our own orchestrator called Cattle. But then when we started working on Rancher 2.0 development, we decided to go ahead with Kubernetes entirely. So Rancher 2.0 is a complete container management platform for all of your Kubernetes clusters. Now, the reason we decided to make this shift is because the tremendous momentum that Kubernetes has gained. So Kubernetes is it is a really well-engineered project, which makes it highly scalable and robust. And these are some of the qualities that definitely all users and companies are looking for. And that is why large software companies such as GitHub have even publicized their use of Kubernetes. And because of all this tremendous like growth that it has shown in the last 2 3 years, even major cloud providers such as Amazon Web Services and Azure have now added their KH offerings. They are also hosted Kubernetes providers. Yeah, so the amount of growth that it has shown is like one of the main reasons that we uh, decided to move towards Kubernetes entirely. So this contribution pie chart shows us that sure, major chunk of the contributions to the Kubernetes project come from independent or open source users because Kubernetes is an open source project. And that is followed by Google because Kubernetes originated at Google. But you can also see this very interesting thing that there are multiple other companies, such as big companies like IBM, Microsoft, HP, and so on, which are actively contributing features to Kubernetes. So I think it's really great to see the growth of an open source project in this way, where even companies are contributing along with other open source users. So Kubernetes is great, and you would definitely like to get started with it. But there are some challenges that you can come across. Now, let's say you have different teams using different infrastructure providers. So, is there a way to make sure that your K8s clusters are deployed consistently across all these different infrastructures? Also, you want to make sure that the access control management across your multiple clusters can get ensured at the same time. Is there a way to do that? Then, is it possible to have a centralized authentication system to integrate with all of your clusters? Is there a way to more efficiently utilize your resources? How can you manage multi-tenancy? Meaning you can have different teams have access to the same cluster, but then you want to provide further more isolation to each team. So how can you do that? How do you make sure that your clusters are highly available? Then there are various Kubernetes concepts such as pod security policies. So you want to make sure that they are enforced across all clusters and all namespaces within those clusters. And last but not the least, you want your application running all the time, which is why you need monitoring to be working fine. Like you need to be able to detect and troubleshoot issues as and how they come. So these are just some of the stats that we pulled off the Kubernetes release cycle. And as you can see, it receives a really high number of commits. It has received like around 50K commits within the last 12 months, I guess. Also, it's one of the projects that has, I think it's, yeah, like it has an insane number of contributions. And because of this, because of how fast Kubernetes is growing, it really doesn't have a concept of long-term support versions. So Kubernetes keeps making new minor release every 3 months. Now, between these releases, a lot can change. Since it is continuously growing, it can happen that you are using some Kubernetes objects which are, say, moved from one Kubernetes API version to another. So you will have to update all of your configuration files accordingly. Or let's say some API version or some object got deprecated. So then again, you will have to make sure that you're not using something which is deprecated. So as you can see, all these changes that keep coming in K8s and the operational challenges that we discussed, all of these combined can be very overwhelming. And it means that Kubernetes has a steep learning curve, and it would be really great to have some help along the way, right? Also, even if you're familiar with Docker concepts, that doesn't necessarily mean that you are also familiar with Kubernetes automatically. So again, you need something to ensure that you using Kubernetes clusters is becomes much easier for you. And that is exactly what Rancher will do for you. So these are some of the great things that Rancher provides, such as an easy to use interface for case configuration and deployment. Like I said, if you have multiple infrastructure providers in use, then you can manage multiple clusters across all of those with the help of Rancher. Rancher also ensures automated deployment of the latest K8s release. Rancher will provide you workload, RBAC, policy, and project management. Now, project is a Rancher concept that we'll take a look at during the demo. And Rancher has amazing 24/7 enterprise grade support. People have really great things to say about our support team, so you can check it out. So Rancher 2.0, a complete container management platform. And these are the different layers at which it kind of functions. So at the bottom of the slide, you can see there are different infrastructure providers. And right on top of it, there are different hosted Kubernetes service providers as well, which means you can have your Kubernetes clusters running on any of these, and Rancher will manage those clusters for you. And you can also start or spin up new clusters, new Kubernetes clusters on any of these via Rancher. Then on top of that, we have the unified Kubernetes management layer, which deals with provisioning of your workloads, upgrades, RBAC, then policies, security, such as like pod security policies, and capacity, which deals with utilization and so on. And on top of that, we have the application management layer, which includes the user interface that I earlier mentioned, then app catalog. So catalog is something which lets you launch any of your applications within Rancher very quickly, and we'll include that in the demo as well. Then the application management layer also includes CI/CD and monitoring and login. So this is kind of a high-level architecture diagram for Rancher 2.0. Now, right in the middle of the screen, you can see that blue box that reads Rancher API server, and that manages all the clusters that you can have running within Rancher. And Rancher also uses etcd, so it's backed up by etcd. And okay, so you can see at the bottom of the slide, there are two objects like called RKE nodes and GKE nodes. And there is an RKE cluster and GKE cluster. So GKE is the Google Kubernetes cluster, and RKE is something called Rancher Kubernetes Engine, which also deploys Kubernetes clusters very quickly. So you can have different types of clusters managed together by the same Rancher API server. So this is the architecture diagram. Now I'm going to go over some of the core Kubernetes objects. Now, these objects are purely Kubernetes concepts, meaning no matter how you start your K8s cluster, whether you're using Rancher or not, they will still remain the same. We are going to look at pods, deployments, services, config maps, and ingresses. So let's start with pods. A pod is the smallest deployable unit in Kubernetes. It usually consists of one or more containers that are co-scheduled and co-located. Each pod is given a unique IP address, and this IP address makes it accessible by all other pods and deployments within a cluster. Now, since these two pods are co-located, they share the same network namespace, which means the containers in a pod can speak to each other via localhost. Now, coming from the world of Docker, this concept of having more than one container running in a pod can get a little confusing, but you don't need to worry about it because as per Kubernetes documentation, the one container per pod model is the most common use case for a pod. So just for this remainder of the training, we can think of pods as containers. But still, here's an example of pod in which two containers, one is an Nginx container and one is a Redis container, are running together. And since they are running in the same pod, they can speak to each other via localhost. Now, this is just a simple spec for pod. Like this is a YAML file which you can use to create your own pod. And you will see further on that no matter which Kubernetes object you're using, some of the fields in the spec remain the same. For example, you will have to specify the API version and kind and name for all the objects. And then in the pod spec, there is a field for containers where you provide the name for your container and what image it should use and so on. Now, replication controller is something that ensures that a specified number of pod replicas are always running. So any controller in Kubernetes tries to make sure that whatever desired state you're giving for your resource is matched by the actual state. It tries to make sure that the actual state matches the desired state. So this was the replication controller, which makes sure that you have a certain number of pod replicas up and running. Replica set is the next generation replication controller. So I think the only difference is the set-based selector support in it. So replica set, this is how it will work. Let's say I said in my spec that I want 12 pods of my application running all the time. And those pods get scheduled across 3 nodes in this way. Now, for some reason, one of my nodes goes down, but I had said that I want 12 pods running at any time. And that's why those 4 pods that were running on the node that went down will get distributed across the remaining nodes that are available. So let's take a look at deployment. Deployments are a level of abstraction above replica sets. Deployments are something that will manage, create and update replica sets for you. So which means you don't necessarily need to create a separate replica set. You can just create a deployment and that will manage replica sets, which will manage the pod lifecycle as well. So along with that, deployments give you many useful features, such as they let you easily scale your applications and they let you perform upgrades, such as rolling upgrades for your application. So when you're writing a spec for your deployment, Kubernetes lets you choose whether you want to update your deployment using rolling upgrade strategy or recreate strategy. And by default, it selects the rolling upgrade strategy for you. And this is how it will work. Let's say you have 4 pods running of a deployment, and all of them are running the version V1 of your app. And now it's time to upgrade your app to the new version V2. So using the rolling upgrade strategy, it can bring up 2 or whatever number of pods that you have specified in your spec to create these 2 new pods. After it creates the new pods, it will start deleting the same number of pods that are running the older version. And once it sees that the new version is running just fine, deployment will remove all the pods that were running the older version of your app. But let's say for some reason something goes wrong. There is a kubectl command, I think it's called kubectl rollback, with which you can roll back to your older version. So as you can see, it makes your application updates pretty easy. This is just a sample deployment spec. Again, it has the same fields such as API version, kind, metadata, and so on. Now, in the deployment spec, you can see that I have mentioned that replicas is 3, which means I want 3 pod replicas running at any instance. And I think in the latest versions of Kubernetes, you need to provide these 2 fields, which is metadata labels and spec.selector.match labels. So what it does is, any pods that this deployment is creating or updating, it makes sure that those pods get this label called app:/nginx, so that it can keep a track of what all pods that it is managing. So we went over pods and we saw how each pod gets a unique IP address. And all other pods in the cluster will try to access this pod using this IP address. But again, we also saw that a pod is an ephemeral entity. And even though if a deployment is there to take care of a pod lifecycle, if a pod goes down and a deployment brings up a new pod in its place, this new pod will get a new IP address. So what happens to all the other applications that were initially communicating with this pod that went down? We need to make sure that there's a better way with which all pods can keep a track of each other, can keep a track of pods they want to communicate with. And that's where a concept of service is helpful. So a service defines a DNS entry that can be used to refer to a group of pods. It provides a consistent endpoint for the group of pods. Now, there are different types of services such as node port, which exposes your service over a same port on each node. Then cluster IP, which is internal within the cluster, and load balancer, and so on. This is how service works. It gets some incoming request, and then based on selectors, it forwards that it forwards the traffic to the pods. This is an example spec of service. Over here, the kind is service, and you will provide some name to it. And you can see in the spec.selector section, we have provided the selector as app:/nginx, meaning it will forward traffic to all the pods that have this selector, app:/nginx on it. And if you recall, when we were creating our deployment, we had provided this match label selector, which means this service can forward traffic to all the pods that are being managed by that deployment. So config maps. Now, when you're running some applications, you might need to provide some configuration values and files to it. Like, let's say you are running an Nginx app, you might want to provide a default.conf file. Or even if you're running some other application which needs some configuration values. So it's not a good idea in these cases to have those configuration values baked into your main container image. Because then every time your configuration changes, you'll have to keep recreating the same image, and then you'll have to redeploy your applications. And Kubernetes provides a great way of handling these things with the help of the object called config map. So a config map allows you to store some arbitrary configuration values and files. And then you can expose this data that is stored in a config map to any pod by providing this config map as environment variable or via local mount, via volume mount. So this is an example where, let's say we have 3 different environments. One is for dev, one for QA, and one for production. And you can see I'm creating 3 different config maps for each. So I can just put data specific to each environment in each of these config maps. And this is an example spec of a config map, where again, you would specify the API version and kind as config map. And I have given name testcm to it, and the data is provided in the form of key value pairs. Now the last object that we look at is an ingress. So ingress defines how the traffic from outside the cluster is routed within the cluster or inside the cluster. And ingress is used to expose your Kubernetes services to the world. It can route traffic to any of the internal services within your clusters based on host and path combination. And Ingress is usually implemented by load balancers, such as if the Rancher default is Nginx Ingress, but you also have HA proxy, AWS, and many other options available. So Ingress resource, just by creating an Ingress resource, you can't just assume that your routing will work. There needs to be an Ingress controller which can make sure that the routing works properly when your Ingress object is brought up. And Ingress controller is something that we'll just take a look at soon during the demo. So this is how it will function. A client is sending some requests which reach your Nginx Ingress controller. And based on the host and path combination, it can know which Kubernetes service to forward this request to. And further, this service, based on the selectors, will know which pods this traffic should be forwarded to. And this is just an example Ingress spec. So I think I'll just pause now for a few minutes to see if there are any questions that I can answer. Matthew, are there any questions?
Yeah, thanks, Rajashree. Awesome getting through that first portion. So there is one, but it's a request from Jovan to talk more about DNS, and I think it has more to do with when we get to Rancher, the Rancher demo. So he says, can you please show how to work with DNS? For example, if we add a domain, domain.com, so that every node gets a subdomain. And he says he was able to do it in Rancher 1.x, but he's having trouble in Rancher 2.0 to do it.
Oh, DNS. Actually, I'm not sure I've worked on that in Rancher 1.6 either. So I don't think I get the question entirely. Meaning,
Okay.
yeah, I'm sorry, I don't think I'll be able to answer that.
Yeah, no worries. And Jovan, if you have another way you want to phrase your question, maybe we'll understand it better. Or you can ask in the user Slack, and you might get more help there. Okay, cool. Yeah, that's all for now, Rajashree. So keep going.
Yeah. Okay, so time for the demo. So first of all, we'll take a look at how you can install Rancher server. We'll start right from there. And please feel free to follow along. So these are Rancher docs, which contain information about all the features that we provide. And please feel free to refer them. So I'm going to go to the Rancher 2.0 docs. Over here, I'll go to the installation section. Within that, let's check out node requirements. So if you want to run your Rancher server container on some node, these are some of the requirements that we suggest your nodes meet. So for example, the operating system requirements list the various operating systems that Rancher supports. And when we say support them and their subsequent releases, we really mean that we have conducted testing and we know that Rancher server will work just fine on these versions. These are some of the hardware requirements. So based on the number of clusters you want and the nodes you want, these are some of the metrics that we suggest you can use. Software requirements. So Rancher server is a container, meaning you can have it running with a Docker run command and then it will run within that container. So for that reason, you need to have Docker installed on your node. And these are some of the supported Docker versions. So again, we say that they are supported because we have done all of our testing on it. But if you were to use some unsupported version and everything on Rancher seems to be working fine, then I guess you can go ahead with it. But these are the officially supported ones. And this networking is also an important section. So it basically means that whatever IP address you choose to run your Rancher server on, it should be accessible. And these are some of the port requirements. This is kind of important, so please ensure that whatever cluster you choose to deploy, you open up the ports that are necessary for that particular cluster. So there are different types of clusters that Rancher can manage. Like first of all, we can let you create clusters on hosted KH providers such as GKE, AKS, and EKS through our Rancher UI. But the Kubernetes cluster will be created by those providers and Rancher will be managing those for you. Then secondly, Rancher can even create Kubernetes clusters for you on different cloud providers such as DigitalOcean. You can just select whichever node you want and we will go ahead and install Docker on it and Kubernetes on it. And if you already have some like clusters running elsewhere, then you can just import them within Rancher and have them managed by Rancher. Oh, also one more way is if you um, the second option that I was talking about, where say you are using DigitalOcean and you want to provision Kubernetes cluster on DigitalOcean via Rancher. So in that case, we also bring up the DigitalOcean droplets for you. But let's say for some reason you don't want Rancher to provision those hosts or those nodes for you. You can use an option where you can have your custom nodes, which already have some Docker version, something running on it. And then Rancher can just provision Kubernetes on it. So for all these four types of clusters, you need to have the port 443 open. This is because we open WebSockets for communicating between the clusters. Now, for the first type of cluster that I spoke about, that is, the Rancher launched Kubernetes, the first type of cluster that you can see here on the leftmost side. Over here, we will be provisioning, like we will be installing Docker and Kubernetes for you. So that's why you need to open a port 22 so that we can SSH into those nodes to install everything that is needed. And for the hosted Kubernetes providers, you also need to ensure that your port 6443 is open so that we can communicate to the K8s API server. So I guess these are all the requirements. And please make sure that you just take a look at these things. So if you come to server tags, it just explains what type of tags you can use for the Rancher images. You can find all these Rancher images on our Docker Hub account. And latest, like the latest tag for our Rancher/Rancher image is the latest development release, but it's really not recommended for production environments. If you find an image tagged stable, then that is our newest stable release, which is recommended for production. Now, there are various installation options, such as you can have a single node Rancher installed, or you can have HA and so on. But for the purpose of this demo, I'm just going to go ahead with the single node install. So the first section tells you about the requirements, which we just saw. Then the second one gives you a command, a Docker run command, which you can use to run your Rancher server container. Now there are four options with which you can do that. So like Rancher, SSL is required when you're using Rancher for security purposes. So there are four options with which you can have this certificate for your command. Like first of all, there's an option of default self-signed cert. So if you're using Rancher in just development or for testing purposes, you can just use this and Rancher will generate a self-signed cert for you, which will be used. Then the second option is if you wanted to use your own self-signed certificate, you can do that as well. The third option, if you wanted to use a certificate which is signed by a certificate authority. And the fourth one is the Let's Encrypt. But again, like I just want to keep this demo as basic and simple as I can. And so I'm just going to use the default self-signed certificate. Now, let's see. Okay, so I had already created this node on which I'm running Ubuntu 16.04, which is one of our recommended operating systems. And I've already installed one of our supported Docker versions as well. So I have this node ready and I just need to paste this Docker run command. So as you can see, it has started pulling the Rancher latest image because I'm just doing this for a demo. It will take some time for the container to be up and running. Let's see. It's because this image was not already available on this node, it takes just some time to pull the image actually and then to start the container. So our container is up and let's just give it a few more seconds before we try to access it. We can keep checking the logs of our container in the meanwhile. And these logs will tell you that what all things it is doing right now. Like it did a couple of things right from the beginning. It created a lot of CRDs. So what are CRDs? Like we saw at we took a look at some of the core Kubernetes resources such as pods and deployments. But since Rancher does much more for you in order to manage your different Kubernetes clusters, we need to add some of our own resources. And Kubernetes is really great with respect to that because Kubernetes lets you extend your cluster by adding any kind of resources you want through one of the methods is by custom resource definitions, and that is exactly what we have done. We have these multiple custom resource definitions created. Okay, let's see. Oh, okay. So when you come here, it will ask you to just accept the certificate because Rancher had generated a default self-signed cert for you, and you just have to do that. And we always enable local auth by default when you are setting up a cluster. So just put some password. Now this is another important setting, which is the Rancher server URL. You need to save this URL and make sure that this URL is accessible to all the clusters. So this is it. This is your Rancher server cluster, which is, the Rancher server, which is up and running through your container. And as you can see, there are different tabs. Like right now, we are on the clusters tab, and there are no clusters created. Now, although local auth is enabled, it is always recommended to have some external authentication provider integrated as well. And it's great because we have multiple options with which you can enable external authentication, such as Microsoft Active Directory. This is pretty cool because you can just provide your Active Directory server details here. And with that, you can set up auths, which means all the users and groups within your Active Directory can have access to your Rancher server. Then there's Azure AD at the same time, which is pretty great. So along with Active Directory, we also have a couple of like LDAP, Open LDAP implementations, such as we have the Open LDAP server, which works in the same way. You provide all the details of your Open LDAP server, and then all the users within it can access Rancher server. Then there's support for free IPA as well. And recently we introduced SAML providers as well. So we have two providers. One is the Ping Identity and one is Microsoft ADFS. Now the backend for our SAML providers, it's the same code that we are using for both these providers. But these are just the providers that we have actually done testing with. Like we have our own Ping identity provider or ADFS identity provider, and we have done thorough testing with these two. That's why we have created like separate providers for them in our Rancher UI. But it's a generic SAML at the backend. So yeah. And last but not the least, there's the GitHub provider option, which I think is pretty cool. It's very easy to set up GitHub auth. Yeah, for as you can see, we have given all the instructions. You just go here. This is your developer applications tab, and you can create a new app. Then you can provide whatever application, like if you want to provide an application name, then you can. And for homepage URL and application callback URL, you just copy paste this URL. And that will generate some client ID, client secret, and set up your auth. So yeah. So actually, for the purpose of this demo, I had just created a separate Rancher server, which is already running because I had to install a couple of things on it because those things can take some time and I didn't want to stall the demo because of that. So let me just switch to that Rancher server instance, which I already have running. So as you can see, I was talking about the GitHub auth and I had enabled GitHub auth in this Rancher server. Okay, so when I go to the same security authentication tab, I still have the same options of authentication providers, but GitHub is already enabled. Now, no matter which auth provider you enable, once you enable it, you will come to the site access section, which will have three options. So if you were to choose the first option, which is allow any valid users, then anyone who can have access to this URL will be able to log into Rancher. Then if you choose allow, so I mean within your like whatever GitHub organization or whatever, then within allowed members of clusters projects, sorry, I mean the second option is allow members of clusters projects and authorized users and organizations. So what this means is you can add any I mean, any users, GitHub users from your organization to any cluster or project. And if you do that, then they will be able to have access to your Rancher server. And this authorized users and organizations is the access control list, which you can see to the right. So you can type into the drop down anyone's name or any group's name that you want to add, and you can just add it. And this drop down shows you what all groups and organizations you already are a part of. So you can add any organization and click on save, which means any users from Rancher Labs organization will be able to log into my server. And the third option is restricting access to only authorized users and organizations, which means we restrict access to only objects like principals that are a part of this list. And we don't provide access to any users or groups who are only members of clusters or projects and not a part of this list. So I'm not going to change anything here right now. I just want to have access for myself. So I'm not going to click on save. Now let's go ahead and check out the different features in Rancher. So first of all, we start with the clusters and how you can add clusters in Rancher. Come to the cluster page. I have already created 2 clusters. I'll just tell you briefly why. Now let's just first go to add cluster. On this page, you can see the 4 different type of clusters that I had mentioned earlier. First one is you can add a cluster via a hosted Kubernetes provider. You can choose from GCE, EKS, or AKS. So what this really does is you will just have to provide your service account JSON file, and we'll authenticate you with the Google API, and then we'll provision the we'll start the cluster over there. But this cluster really gets started on GC, and like everything is started by GC. So we are just providing a way to manage that cluster within Rancher. So you can just provide some name here and you can enter your service account JSON file. Let's try doing that. Training. So once you do that, once it authenticates you, it gives you these options such as which zone you want the different nodes to be started in, or what machine type and so on. And you can just go ahead and click on create. And I followed the exact same steps and already created this this cluster called, well, I've named it Rajashri Training GK, but I did the same exact steps. So let's check out the second option, which is creating a cluster from nodes in an infrastructure provider. So over here, you have these options available. So let's take, for instance, DigitalOcean. You can just go to DigitalOcean and you'll have to provide some cluster name to it. Now, one thing, I think I forgot to show this for the GC as well, but even for the GK as well, but like all the clusters will have this option while creating, which is that of member roles. So when you click on this member roles section, you can control what members will have access to this cluster. Like you can add users or groups as members to this cluster. So this is how it works. Since I am creating the cluster, I am definitely a cluster member. But because I'm creating it, I get the role of a cluster owner. Now I can add anyone I want to add. Let's say, for example, I want to add Matthew. I can just go ahead and search his name. And because the GitHub auth is enabled, it will pull up all users that will have that username. And if I know the username, I can just add anyone. Or let's say if I want to add a group, then I can do that as well. As you can see, the Rancher Labs organization shows up here too. And then when I specify the name of the user or the group that I want to add, I can select what role I want that user or group to have within my cluster. So if I select the owner role, then that the user will have the same kind of access as I do. if I create the user with the member role, then they'll have some limited, like some restrictions on what all they can do. Then there's a read-only role, which, as the name suggests, gives read-only access. And if you select this last role, that is the custom role, it opens up all these cluster permissions. So from this, you can choose any combination of permissions that you want to grant to this user or group. So this is how you can add members to a cluster and give them access. Then there are different cluster options, such as which Kubernetes version you want running. Now we are looking at the second option, where we will be installing Docker and Kubernetes and like provisioning the cluster entirely for you. So that's why you need to take a look at these options. We have selected what we think are the best options by default, but if you want to change something, it's up to you. So we have selected this Kubernetes version, but you have these options available. Then Rancher also sets up the networking. So we have network providers as well. And you have these three options, but Canal is supported by default, like, I mean, selected by default, because Canal is kind of, this is what I've heard. I mean, I don't have much networking knowledge, but I've heard that it's kind of the best among these because it provides best, like, good features from both of the providers, such as it provides project network isolation. You can either have it enabled or disabled depending on what you want. Now, when I was showing you the various Kubernetes objects and when I was talking about Ingress, I had mentioned that you also need to have like some Ingress controller running so as to respect the routing, like the routes provided within any Ingress. And this is what we do. Like when Rancher is provisioning a Kubernetes cluster, we enable the Nginx Ingress controller by default. So this is metrics server monitoring. Whether you want it enabled or not, it's up to you. Then you can have some pod security policy support enabled. And pod security policies is a Kubernetes concept, which I'll cover later on. Over here, you can choose if you want a supported Docker version or not. And okay, so now over here, you have to create a template. And I've already created one, but creating it is pretty easy. So sorry, yeah. You just click on this. You have to provide your DigitalOcean access token. So, okay. Once you provide it, we authenticate you, and then you can click on next and go ahead to configure your droplets. You can select whatever region you want, which image you want. Also, the droplet size is important. So by default, we have selected some size, which I think is at least bare minimum necessary to have all the various components of the cluster running. So make sure that you have provided a sufficiently sized droplet. And you need to provide some name for your template. If you want to add some labels, maybe it's up to you. And you can create a template. I've already created this one. So now you need to provide some name prefix for your node. We'll see how that works later on. Along with that, you also need to provide some roles to your node, such as etcd, control plane, worker. And this governs what all components of the cluster will be running on each node. So I have already created a DigitalOcean cluster. Now, the reason why I had already created these two clusters is because sometimes it can take some minutes for the clusters to come up, and I just didn't want to do that during the training. That's the only reason. Now, let's check out the third option, which is creating a cluster from your existing nodes. So hang on just a second. Okay, so again, over here we have the member roles section where you can decide who gets access to your cluster. You need to give your cluster some name. Then again, you have the same cluster options available. You have selected what we think are the most suitable ones by default. And again, in this option, Rancher will be provisioning the Kubernetes cluster for you. So we are installing KH for you. And we are by default installing the Nginx Ingress controller, and we have selected Canal network provider and so on. So let's hang on, I've provided the name. So let me just go ahead and click on next. Now over here, you can specify what all roles you want any node to have. So I just want to create a single node cluster, and I wanted to have, I needed to have all 3 nodes. Now the second option or the second section will give you a Docker run command, and you just need to run this command on your node. So let's see what happens when I do that. I have this custom cluster running, and I have installed Docker on it, but as you can see, there are no containers running. So I'm just going to copy and paste this command here. And it's pulling the Rancher/Rancher agent image, and it is something that we need in order to install and have Kubernetes running on your nodes. Okay, so as you can see, it has created whatever containers it needs to. Yep. And when you go back to the UI, you can see this message that one new node has registered. So it's pretty cool that it tells you that how many nodes you're running this command on, whether those many nodes have been registered in the cluster or not. It lets you know that. So I'm just going to click on done. And as you can see, my cluster is at the provisioning state. And the UI is pretty great. It lets you know where exactly your cluster is at, like what state it is in. So for example, these 2 clusters are active, and this cluster is provisioning. So the UI keeps telling you what all different steps it is doing. So I think that's pretty great. Now the last option, that is of importing an existing cluster, which means you have already provisioned a Kubernetes cluster by one way or the other, and you would still like Rancher to manage that cluster for you. So the way to do it is, okay, yeah, you just have to provide some cluster name, and you will just provide some you will just provide access to some users or groups that if you want to. And other than that, there's nothing else to do because you already have Docker, Kubernetes installed, and even a Kubernetes cluster functioning. So just click on create. Now this will give you some commands. So the first command means that if your cluster already has a cluster admin role defined, then you need to run this command to make sure that the cluster admin gets certain privileges that Rancher needs. Then secondly, if you are running on an existing Kubernetes, you can run this if you're not using the SSL certs option, but if you are, then you will go ahead with the third option. So I had already created a cluster using RKE. RKE, as I said earlier, is the Rancher Kubernetes engine. And I'm just going to run this command for it. For those of you who aren't familiar with this, when you're running a kubectl command, you need to make sure that you have a kube set up. So usually if your kube config is saved in kube/config path, it gets used directly. But if it is not, then you can provide the path to it using the --kube-config option. This is the kube-config option, the kube-config file that I want for my cluster. Okay, so looks like this command did a few things, which is it created some of the Kubernetes objects that Rancher needs. For example, it created this namespace called cattle system, then some service account cluster role binding, and so on. Now, these are all the things that Rancher will just add on your existing cluster so that that cluster can get managed by Rancher. When I go back to the UI, I can see that my imported cluster is already showing up on Rancher server. So we have all 4 clusters up and running. Yeah. And I can just select this DigitalOcean cluster and see it shows me what all is running, how many nodes are running, which version of Kubernetes is being run on it, and so on. Yeah, I think I can pause here to take any more questions that have come up. So Matthew, are there any questions?
There's not actually. So you're doing great. Keep going. There's a lot of people on the line, but I guess they're just paying attention. And everybody, if you do have more questions, please ask.
Yeah, please feel free to ask. Okay, so
Oh,
let's
you
go
know
ahead.
what? We just got a question. Just now.
Okay, sure.
So
Yeah.
why don't we just take that one? So it's from Andre. Asks if there is a best practice for managing a Rancher 2.0 cluster. Do I just install a single node somewhere, or are there any recommendations?
So I think most of it is covered by our documentation. So that would be a really good place to refer that. But I think like usually having multiple nodes is better. Like usually having your HCD running on more than one node is recommended.
Right. Yeah, he just asked to follow up to, he said, do I install a single node somewhere or do I deploy it also in a replicated manner?
With replicated manner, are you saying like high availability install or?
Yeah, I'm not sure. Yeah, he says yes. That's what he means.
Okay, yeah. So I think well, we have many of these options for the high availability install as well. And I'm not sure, but I think that is more recommended. So you can go ahead and check it out. Yeah,
Cool.
I hope
And
that
just
helps.
so nice, just so everybody knows, we will be doing a training on high availability sometime soon. So stay tuned for that. And that's it. Keep going on, Roger Tree.
Okay, awesome. So yeah, I'm in this DigitalOcean cluster that I created. And as you can see, there are some options here, such as launch kubectl kubeconfig file. And also any resource that Rancher creates, it will give you these options, which is you can edit it or you can view it in API, or of course you can delete it. And this view in API section is something we'll check out soon. So first of all, let's take a look at this kubeconfig file. And this is pretty cool because Rancher knows which cluster you're on, so it can switch context accordingly and give you the kubeconfig that is for the cluster that you're on. And if you want, you can put this in your path uh, tilde slash dot cube slash config. And this is what I was talking about earlier. Like if you have any kube config already in this path, then you don't need to provide this dash dash kube config flag. So, but let's say you don't want to do that. Like you don't want to copy paste the kube config from here and then run it locally for some reason. You can just click on launch kubectl, which again gets the context that you're on, the cluster that you're on, and it just directly launches a kubectl shell for you. So let's see what all I have running here. Okay, it's just showing me the Kubernetes service, and I'm sure most of you are familiar with this, but if you want to know what is running in a particular namespace, then you have to provide the namespace for it. Or if you don't know what namespace you're like some object is running it, then you can just give this all namespaces flag. Oops, why am I doing so many typos today? Okay, so when you give the all namespaces option, it lists all the objects, all the resources that were created in different namespaces, and then you can go ahead and take a look at any of them separately. Now let's go to the nodes. So for the DigitalOcean cluster, I had only created one node. And as you can see, it is listed here. Again, you have the same options of editing it or viewing it in API and so on. So when I click on this, it gives me the different stats for my node, such as it is showing what the kubelet version and so on, what operating system is being used. And then over here, there are some more detailed stats for my node. You can take a look at them if necessary. And it is showing what all roles are being run on that node. So when I was provisioning this cluster, I had only selected one node and I wanted all the roles to run on the single node. But again, I only did this because I'm not actually running many applications or actually anything on this node. I just wanted to show it for the demo. And whatever is recommended is provided, is very well documented. So please make sure that you refer that as well. Okay, so now okay, yeah, let's take a look at this. Now, let's say I go to my GKE cluster. Again, on the nodes page, I can see the different nodes that were created for this cluster. And you can see that all of them have the role worker. Now this is because GK it's pretty great at abstracting the details of Kubernetes. Sorry, what I mean is it hides the HCD and control plane components from the user so that the user doesn't need to modify that or can't like accidentally do something to it, and it only gives you nodes with the worker role on it. That's why you can see all the nodes having the worker role. And let's see like one difference in this. So you can see that this is the notes page for GK. Let me go back to DigitalOcean. Over here, you can see that I have this option of scaling up or down the number of nodes that I have running, whereas I don't have the same option for GK. I don't even have it for the imported cluster or even for the custom cluster. Now, the reason I only have it for DigitalOcean is because it comes under the second category of cluster, which is cluster created from nodes in an infrastructure provider. And the reason being, like we are using infra providers, and we ourselves are provisioning nodes for you over there. So we ask you to create some node template beforehand, which I had created, which I'd shown you how to create. And so because of that, if I just click on this plus sign, then it starts creating or provisioning another node for me using the same exact template that I had provided initially. So this makes scaling up and down of nodes very much easy. And again, it's going to use the exact same template, and whatever prefix you had provided, oh, I guess I clicked on plus again. Whatever prefix I had provided will like get used for creating this node as well. Okay, so it will take some time for the nodes that I created to come up, and in the meanwhile, the UI will just display this message to let you know that your cluster is being updated or provisioned, whatever. Okay, so these are the different node drivers that we have. Some of them are the ones that we have enabled by default or made them active by default. But if you want to activate some other option, you can do that. Now it will take some time for this cluster to be up and running again. I mean, up and running as in updated again. But in the meanwhile, let's go to my GK cluster and take a look at what all I have within it. So let's go to the storage tab. Now, storage, the Kubernetes concepts for storage are pretty awesome, I guess, because let's say like you want some form of persistent storage within your cluster. So Kubernetes provides a way of doing that as well. For that, Kubernetes uses three core objects that are persistent volumes, persistent volume claims, and storage classes. So persistent volume is basically a volume or like which will live outside of the life cycle of your pod. What I mean is when you're creating a pod, you can do a volume mount, but when the pod dies, that volume also goes away. So persistent volume is something that will stay around irrespective of whether your pod died or not. And persistent volume claim is something that like a pod will use to bind to a persistent volume. So when you're actually provisioning these, like the storage, Kubernetes can do this provisioning in two ways. One is static provisioning and one is dynamic provisioning. So what static provisioning means is your cluster administrator should have created a certain number of persistent volumes beforehand. And then whenever some pod is trying to create a PVC, like a persistent volume claim, it can just bind to an existing persistent volume. But let's say you don't know beforehand how many persistent volumes are needed, then you can go with the option of using dynamic provisioning. And for dynamic provisioning, you need to use storage classes. So I think we have great documentation on that as well. And I'm not particularly an expert in this area, but please make sure that you refer those talks, or the Kubernetes documentation for them are also pretty great. So make sure you check it out. But if you come to storage and persistent volumes, you can click on add volume. Now over here, there are various options for a volume plugin that you can choose from. So you just need to click on this drop down, and these are all the volume plugins that we can allow you to add to your cluster. So for example, Amazon EBS Disk, Azure Disk, and so on. So let's say I click on one, and then I have to do some plugin configuration based on the volume plugin that I selected. So depending on the volume plugin that I select, I'll have different types of options. So for Amazon EBS disk, these are the options that I have available. And these are some of the advanced options such as single node read, write, read only, and so on. Like it defines how many ports can your volume be mounted on and what kind of access it has and so on. So instead of EBS disk, let's say if I select Azure disk option, then you can see that my plugin configuration options also changed accordingly. And now the second concept that I was talking about is storage class. So you can, you can just add any storage class that you want. Again, while adding a storage class, you need to select what provisioner you're using. Also, when you're using persistent, like adding volume plugins and all, please make sure that you are using something that is within the same, like supported by the same cloud provider on which your cluster and other resources will be running, because usually I think the cross cloud provider options have caused some trouble. That's why it's better to make sure it's the same cloud provider. So yeah, you can create a storage class like this. And once you create a storage class, even if a persistent volume is not created beforehand, when a persistent volume claim gets created, the storage class can dynamically provision a persistent volume for it. Okay, so the next thing that we'll take a look at is the concept of projects and namespaces. I had mentioned projects earlier. So projects is a rancher concept. Kubernetes doesn't have a resource called projects. Now what it does is projects basically groups one or more namespaces together. So in a Kubernetes namespace, you can define what all resources you want running in one namespace, and you can also provide access to only certain users to that namespace. But apart from that, let's say you have multiple teams running in a same cluster, and you want to make sure that like one team has access to multiple set of resources, but then it's again isolated from other teams. So that's where like a concept of project is pretty useful. You can group multiple namespaces together and provide access to only some users to that project. And whenever you create a cluster, we will always create two projects for you. One is the default project and one is system project. So you must have seen that when you create a Kubernetes cluster, there is always a default namespace created for you. That's what we kind of do with the project, default project as well. So in the default project, we only have one namespace running initially, which is the default namespace. And in the system project, we have these namespaces running, which is cattle system, kube public. This cattle system namespace has all the resources that Rancher needs to be running in your cluster so that Rancher can manage your cluster. So it's really recommended that you don't modify these things. Same with kube system. I'm pretty sure we don't need to change any of the kube system resources, and because we might accidentally make something wrong with our cluster and we don't want that. So we can just leave these things. If you want to add a new project, you can just go and click on add project. You provide some name to it. And again, while creating the cluster, we saw that you can give access to different users and groups to a cluster, and you can do the same with the project as well. It's the exact same way. You will just look up someone, and yeah, you can just add some role for that user. You can make that user or group an owner, member, read-only member, or a custom member as well. I think one more thing that I forgot to mention was that we saw how you can add members to a cluster or project while creating them. But let's say even after creating them, you want to add some more users or groups. You definitely have a way of doing that. So if you go to this cluster level, and if you go to the members tab, you can see that right now I have only one user in it, which is me, and I have the role of cluster owner, but I can just go here and then add any members that I want. And it's again the exact same way. So let me go back to my project for now. Okay, so I hadn't created the project, so I'm just going to create that. Okay, right now I have one project running, which it's actually not doing anything because I don't have any namespace or any resources within any namespace in it. But we are going to add some workloads to it later on. Okay. Now, let me go to this namespace. Sorry, let me go to this project. This demo project, you can see the first page that you will see is the workloads page, which will show if any workloads are running at all in your project. Then there's the load balancing tab. You can see right now I have nothing running, and we are going to run something soon. But first of all, let's take a look at this the catalogs feature that I've mentioned. So to launch any catalog app, you need to add some catalog to your Rancher server. Now, what is a catalog? For that, again, I need to go to the global view of Rancher server. And over here, I'll go to the catalogs tab. Now, you can see that there are some of the catalogs that are already available. For example, we have a library catalog, which is already enabled. Now, what a catalog is basically a library or a repository containing some charts that you want to later install in your Rancher server. So library is an official repository of curated app templates that are maintained by Rancher. We also can allow you to add Helm stable, which is an official repository that is maintained by the Kubernetes community. But let's say you have your own repository of application templates of Helm charts that you want to add. You can just go here, click on add catalog, provide some name to it. You need to provide your catalog URL. Now it's my GitHub repository. And let's say I want to provide only one branch of it. So if you're providing your GitHub repository as the catalog URL and you want to provide a particular branch in it, make sure to include the .git option at the .git extension at the end. And then you can just type in any branch that you want and then just create it. But right now I don't want to add any new catalog. So this is how you can add a catalog to your Rancher server. And going back to how you can launch an application from this catalog that you've added, you need to go to any project in your cluster. For now, I'm in the demo project of my GK cluster, and I'm going to click on launch. When you come to this page, you will see different application templates. So you have different ways of filtering them out based on, say, categories or based on the name of the catalog. Right now, I have only one catalog, so all catalogs or the library option is one and the same. Now you can scroll through these and find whichever application template you want, or you can just go ahead and if you know you're looking for a particular app, you can just type in its name. Now let's say I want to launch the Grafana app. Now these are some of the things that were provided in the in the application template, and yeah, some of the default options that Rancher selected. And okay, over here you can take a look at the various configuration. Okay. Oops. Okay, for some reason it's okay. It's giving me some trouble, but let's see what to do. Oh, okay. I'm just going to quickly go ahead with the remaining things that I want to discuss. So first, well, if you were to launch any catalog application, usually everything will run fine. I don't know, for some reason something is going wrong right now, but like we have other previous recordings on which you can see how you can launch an app and how they can run just fine. Now I'm going to talk about the API part of Rancher. Let's say you want to view something in API, and you can do that. And by using the API UI, you can also create any of the resources that Rancher UI lets you create. And let's see. Now, the last thing that I want to talk about is the CLI option. So over here, you can download the CLI. So let me go to this is what I downloaded, and over here I have the binary available. So let's see what all I can do here. So I first need to log in, and for that I can like this shows me all options I can choose to log in. I need to provide a token which I can get from the Rancher UI for myself. So the API keys. Yeah, I'm just going to get this token, and I also need my Rancher server URL. Okay, so well, these are some of the features. You can select which context you want and all. And you can also take a look at whatever commands we have other than that. And I guess that's it, Matthew. That's all that I wanted to share.
Okay, awesome. All right, well, so we do now have a bunch of questions, so let's start going through these. Um, we'll just start with a question from Thorstein, who asks, would it be possible to grant access to namespaces directly? Or is the permissions handling done only on a project level? I.e., if I give access to a project, the user would always get access to all namespaces in said project.
I'm sorry, can you repeat the question again? I guess I was not able to hear
Yeah,
you
yeah,
correctly.
yeah, sure, no problem. So it's about granting access. So the question is, would it be possible to grant access to namespaces,
Oh,
or is the permissions handling done only on a project level?
well, through the Rancher UI, you can only add members to a cluster, like to a project. But if you, the Kubernetes concept, like Kubernetes has some concepts such as cluster role binding or role binding, through which you can provide access to a particular like resources in a particular namespace to only a certain set of users. Yeah.
Okay, sweet. Awesome. And if Thorsten, you have a follow-up, please ask. Okay, the next one is from Prashant, who asks, can we auto-scale pods and nodes in managed Kubernetes through Rancher?
Auto scale pods and nodes. So yeah, for the scaling up of nodes, like scaling up and down of nodes, like we saw, you can do it if your K8s cluster is created on some like nodes that are on some infrastructure provider. But auto scaling, we don't support it through Rancher UI right now, like through Rancher right now, but we are looking towards adding like features for that as well. And pod, there is the Kubernetes horizontal pod autoscaler. Like I'm sure you can use that.
Awesome. And we have an article on horizontal pod autoscaler too. So if you check our blog, it's from last month. Okay, the next one is from Nicholas, who asks, does Rancher support GitLab?
Do you mean GitLab authentication provider or
Probably that's what he means. All he
yeah,
says is
no,
it doesn't
yeah,
support
no,
GitLab.
not as of now.
Okay. The next question is from Dimitro, who asks, if I'm going to use Rancher server as a single node solution, do I need to take care of whether a Rancher server backup? Are there any possibilities to back up the configuration of my Rancher server?
I think the Rancher API server itself is backed up by etcd, and we have some good blogs on that. So I think Matthew or myself, we can am I correct, Matthew? I think we have a blog article on that, right?
Yeah, we do. It's from over the summer from on backups. So if you just scroll back through the blog, you will see that. Um, there's actually a couple more questions around backups, Rajashri. So you might have something more specific on these. But this one is from Jovan, who asks, is there a way through Rancher to manage backups of volumes if it's NFS or local disk?
Backups of volumes, meaning whatever persistent volumes you have added on your Kubernetes cluster, is it? So I think for that, if your cluster were to go down, I mean, this is what I think. If your cluster were to go down, then that persistent volume data is also not available to your cluster anymore, but I might be wrong. So, but yeah, this is what I think.
Okay, cool. Let's see. David asks, is it possible to integrate Rancher with other load balancers such as F5 or NetScale?
Yeah, you can have other load balancers.
Cool. Any elaboration you want to give, or should I go to the next?
Yeah, can you go to the next, I guess, because I don't have that much information on this area.
Okay, cool. Um, the next question is from Prashant again, who asks, can we trigger application deployments on Kubernetes from a CI job through Rancher?
Yeah, I mean, if you want to launch some applications through a CI job, I guess that should be possible because the launch option also you can do it via an API call. So I think it should be possible.
Okay, awesome. And you might want to check out our CI/CD recorded meetup from August. There's a lot there, and it also talks about GitLab too, Nicholas. Let's see. The next one is from Robert. So Robert, this is kind of a lengthier question. Robert asks, can the run of the initial rancher be done in a local Docker, then have it generate a trio of etc and control plane nodes in a data center, followed by removal of the local run? The result is a working rancher cluster in the data center. Is this possible?
Okay, I'm kind of finding it hard to follow the question. So you want the Rancher server container, like the Rancher server running out of a container, but then, um, sorry, can you repeat the question again?
Yeah, I will repeat it. And maybe, Robert, you might want to rephrase this. So he says, can the run of the initial rancher be done in a local Docker, then have that rancher generate a trio of etc and control plane nodes in a data center, then remove the local run or the local version of rancher? The result would be a rancher clusters in the data center. Is that right? Is that possible?
I believe when you say that you're doing the initial run out of local Docker, you are using the Docker run command to start up your Rancher server. And if you were to remove that, then your Rancher server will get removed. So, like, even if it is backed up, then I don't see how the Rancher server itself is running later on.
Cool. Okay. Yeah, Robert, if you have an elaboration for what you're thinking, please send it to us. Um, and then David asks, is Rancher 2.0 the stable version for production, or do I still need to use Rancher 1.6?
So Rancher 2.0, oh no, yeah, Rancher 2.0. Well, we have the Rancher/Rancher colon stable tag. So that means that we do recommend using whatever comes under the stable tag under production, and like we have some 2.0 releases which you can use definitely.
Okay, sweet. Awesome. All right. The next one is from Alexander, who says, rancher management is separated from clusters. How to secure? Wait, let me just read the question because you might need to rephrase this, Alexander, but I'm going to try to read it and see registry, see if you understand. So he says, the rancher management is separated from the clusters. How to secure to have it always online if something happens to the server where the rancher administration tools are installed? That's the question.
Well, your Rancher server, the I mean, wherever it is running, that always needs to be up. So, I mean, yeah, you always need to have your Rancher server up and running and accessible.
Yeah, okay. Okay, cool. All right, let's keep going then. Devin asks, and this might not be possible with the time we have remaining, but he asked, Registry, can you demo deploying a container manually without the catalog, something that has a PVC volumes, a config map that is passed through as environment variables?
Oh, so for that, I don't have a pod which is like which has a volume template that will create a PVC. So I'm sorry about that, but definitely check out the Kubernetes documentation. And like you said, we don't have enough time remaining. So for me to create a YAML and actually launch that will take some time. But I like the Kubernetes documentation has really great examples on how you can do that and how you can use persistent volumes along with stateful sets to bring up even MySQL and all on your Kubernetes clusters. So please, yeah, please check it out.
Okay, sweet. Awesome, thank you. All right, let's see, next one. This is from Nicholas, who says, I've got a case study. I see how to use Rancher to run an application on multiple nodes and have the app always on. But does an application for computing data use all the cluster resources of all nodes?
Uh, I'm sorry, can you repeat it again?
Sure. Yeah, I think it's a little hard to understand, Nicholas, so you might also need to rephrase this. But he says, I see how to use Rancher to run an application on multiple nodes to have the application always on. But does an application for computing data use all cluster resources of all nodes? I guess maybe he's asking about like cluster resources for all nodes for an application, and can you kind of segment off different compute
Well,
resources or something like that?
so the application, okay, so depending on how many resources are left on any node, the scheduler will schedule those applications for you. And I mean, if it's a computing intensive application, then I imagine it would be utilizing more CPU than any other applications. But as long as you can add more nodes, I think that should be fine.
Okay, cool. Yeah, he clarified and he added, I understand how to use Rancher for load balancing, but how do you aggregate all of the resources when I have one cluster and 7 nodes, for example?
How to aggregate all of the resources.
Yeah, because he has one cluster and 7 different nodes.
Right. But so there are different resources, right? Like there can be pods and deployments and services. So when you say that you want to aggregate all of those resources across 7 nodes, I'm not sure what that exactly means. Yeah, I'm not sure. Can you please share this question in the Rancher users Slack channel so that
Yeah, that's a good suggestion. Cool. So Nicholas, if you could go to the user Slack and maybe share it there, you might have better luck. So we are actually right out of time. So I am going to just share my screen one more time because there's a couple more links to give you guys just to make sure that you have them. So again, we've been referencing this the Slack channel, slack.rancher.io, and the Kubernetes channel, for Kubernetes specific stuff. And that's all we have. I want to make sure that everybody does know we will be sending out a recording of this session along with the slides and the questions that were asked so that you can follow up if you want to. And hopefully you got something from today's session. We do this every week, so that if you need a repeat, we'll go through it. And please stay tuned for different kinds of trainings that we're working on to get out to everyone. So that's all we've got. Rajashri, thank you again for taking the time to do this and stepping up. It is so helpful.
yeah, thank you so much for having me.
Yeah, absolutely. All right, everybody, have a good rest of your week and coming weekend. Talk to y'all soon.